Dear students, greetings for the day. Today we will discuss about types of looms. Weaving is the process of producing a fabric by interlacing warp and weft threads. The machine used for weaving is known as weaving machine or loom. Weaving is an art that has been practiced for thousands of years. The earliest application of weaving dates back to the Egyptian civilization. Over the years, both the process as well as the machine has undergone phenomenal changes. As of today, there is a wide range of looms being used, right from the simplest hand loom to the most sophisticated loom. Classification of looms. Looms are classified according to their filling insertion mechanism. This classification is as follows: shuttle, shuttleless, projectile, rapier, air jet, water jet. Types of looms. Backstrap loom. A simple loom which has its roots in ancient civilizations consists of two sticks or bars between which the warps are stretched. One bar is attached to a fixed object, and the other to the weaver, usually by means of a strap around the back. On traditional looms, the two main sheds are operated by means of a shed rollover which one set of warps pass, and continuous string headles which encase each of the warps in the other set. The weaver leans back and uses his or her body weight to tension the loom. To open the shed controlled by the string headles, the weaver relaxes tension on the warps and raises the headles. The other shed is usually opened by simply drawing the shed roll toward the weaver. Both simple and complex textiles can be woven on this loom. Width is limited to how far the weaver can reach from side to side to pass the shuttle. Warp-face textiles, often decorated with intricate pickup patterns woven in complementary and supplementary warp techniques, are woven by indigenous peoples today around the world. They produce such things as belts, ponchos, bags, hatbands and carrying cloths. Supplementary weft patterning and brocading is practiced in many regions. Balanced weaves are also possible on the backstrap loom. Warp-weighted loom. The warp-weighted loom is a vertical loom that may have originated in the Neolithic period. This loom was used in ancient Greece and spread north and west throughout Europe thereafter. Its defining characteristic is hanging weights, loom weights, which keep bundles of the warp threads taut. Frequently, extra warp thread is wound around the weights. When a weaver has reached the bottom of the available warp, the completed section can be rolled around the top beam, and additional lengths of warp threads can be unwound from the weight to continue. This frees the weaver from vertical size constraints. Hand loom. A hand loom is a simple machine used for weaving. In a wooden vertical shaft looms, the headles are fixed in place in the shaft. This loom is powered by hand. The warp threads pass alternately through a headle and through a space between the headles, the shed, so that raising the shaft raises half the threads, those passing through the headles, and lowering the shaft lowers the same threads. The threads passing through the spaces between the headles remain in place. It is a manual operating system. Shedding is done by pressing the treadles pedal, and picking and beating is done manually. Hand looms yield less production compared to power loom. It can be operated at slow speed only compared to high speed of power looms. Initial investment is very low compared to power loom. Hand looms are fundamentally different from power looms. Motion of the hand loom is operated by skillful human hands, without using any source of energy like electricity, water, air or sun to drive the motion of the loom. Fabric is woven on hand loom by interlacing of warp, running lengthwise, and weft or filling, running widthwise. Warp threads are raised and lowered by manual shedding motion to form shed. Through this shed, the shuttle is passed carrying across the weft thread, which is beaten against the woven fabric by the movable comb-like frame or reed. When the headle is shifted, the two sets of warp reverse position, binding the weft into the fabric and opening other shed. Hand loom weaving involves all the three primary motions are carried out by the weaver manually for weaving of the fabric by interlacement of warp and weft. Basically, there are two types of hand loom: frame loom, pit loom. These could be further divided into fly shuttle and throw shuttle looms. In a typical frame loom, as used previous to the invention of the flying shuttle, the operator sat with the newly woven cloth before him or her, using treadles or some other mechanism to raise and lower the headles, which opened the shed in the warp threads. The operator then had to reach forward while holding the shuttle in one hand and pass this through the shed. The shuttle carried a bobbin for the weft. The shuttle then had to be caught in the other hand, the shed closed, and the beater pulled forward to push the weft into place. This action, called a pick, required regularly bending forward over the fabric. More importantly, however, the coordination between the throwing and catching of the shuttle required multiple operators if the width of the fabric exceeds that which can be reasonably reached across, typically 60 inches, 150 centimeters, or less. Frame looms are useful for production of designed fabrics like bed sheets, heavy furnishings, towels, dress material, stripe and check material, bed covers, gauze cloth, etc. as in Kerala, Punjab, Tamil Nadu, Andhra Pradesh, West Bengal, Assam, etc. Also woven on the frame loom are ordinary saris with plain border, saris with extra warp and cross-border designs. Pit looms. The weaver sits with his or her legs in the pit where there are two pedals which manually open the warp threads, allowing the weft shuttle to pass along between the weave. This type of loom leaves the weaver's hands free to pass the weft shuttle from side to side and to compress the weaving as they go. Often the women assist by threading the cotton onto the bobbins that are used on the weft shuttle. Most hand loom weavers use the pit, treadle, loom, which is useful when little wood is available for construction. Two types of pit looms are in operation. One is throw shuttle pit loom and another is fly shuttle pit loom. The throw shuttle is a loom in which the shuttle is thrown across the shed by hand. Until the invention of the fly shuttle sleigh in England in the 18th century, the throw shuttle pit loom was the most commonly used loom. Fly shuttle pit looms. In a fly shuttle loom, the shuttle is sent across the shed by means of a mechanical pickup. This is an improved type of loom, which increased 3 to 4 times the production of the weavers. It has all the advantages of the throw shuttle, except for weaving intricate extra weft patterns. This loom has enabled the hand loom industry to capture a section of the market steadily with hand-woven products like color bed sheets, towels, handkerchiefs, door curtains, bed covers, quilt cloth, color shirting cloth, napkins, etc. Flying shuttle. Hand weavers could only weave a cloth as wide as their arm span. If cloth needed to be wider, 2 people would do the task. Often this would be an adult with a child. John K. 1704–1779, patented the flying shuttle in 1733. The weaver held a picking stick that was attached by cords to a device at both ends of the shed. With a flick of the wrist, one cord was pulled and the shuttle was propelled through the shed to the other end with considerable force, speed and efficiency. A flick in the opposite direction and the shuttle was propelled back. A single weaver had control of this motion, but the flying shuttle could weave much wider fabric than an arm's length at much greater speeds than had been achieved with the hand-thrown shuttle. The flying shuttle was one of the key developments in weaving that helped fuel the Industrial Revolution. The whole picking motion no longer relied on manual skill, and it was just a matter of time before it could be powered. The flying shuttle employs a board, called the race, which runs along the front of the beater, from side to side, forming a track on which the shuttle runs. At each end of the race, there is a box which catches the shuttle at the end of its journey, and which contains a mechanism for propelling the shuttle on its return trip. The shuttle itself has some subtle differences from the older form. The ends of the shuttle are bullet-shaped and metal-capped, and the shuttle generally has rollers to reduce friction. The weft thread is made to exit from the end rather than the side, and the thread is stored on a pern, a long, conical, one-ended, non-turning bobbin, to allow it to feed more easily. Finally, the flying shuttle is generally somewhat heavier, so as to have sufficient momentum to carry it all the way through the shed. The hand loom sector plays a very important role in the country's economy. It is one of the largest economic activities, providing direct employment to over 65 lakhs persons engaged in weaving and allied activities. This sector contributes nearly 19% of the total cloth produced in the country and also adds substantially to export earnings. It is unparalleled in its flexibility and versatility, permitting experimentation and encouraging innovations. Draloom. A draloom is a hand loom for weaving figured cloth. In a draloom, a figure harness is used to control each warp thread separately. A draloom requires 2 operators, the weaver and an assistant called a draboy, to manage the figure harness. Dobby loom. A dobby loom is a type of floor loom that controls the warp threads using a device called a dobby. Dobby is short for drawboy, which refers to the weaver's helpers who use to control the warp thread by pulling on draw threads. A dobby loom is an alternative to a treadle loom. Both are floor looms in which every warp thread on the loom is attached to a single shaft using the head-dull. Each shaft controls a set of threads. Raising or lowering several shafts at the same time gives a huge variety of possible sheds through which the shuttle containing the weft thread can be thrown. A manual dobby uses a chain of bars or lags, each of which has pegs inserted to select the shaft to be moved. A computer-assisted Dobby loom uses a set of solenoids or other electronic devices to select the shafts. Activation of these solenoids is under the control of computer program. In either case, the selected shafts are raised or lowered by either leg power on a Dobby pedal or electric or other power sources. On a treadle loom, each foot-operated treadle is connected by a linkage called a tie-up to one or more shafts. The tie-up consists of cords or similar mechanical linkages tying the treadles to the lambs that actually lift or lowers the shaft. Most 8-shaft floor looms have only 10 to 12 treadles due to space limitations. This limits the weaver to 10 to 12 distinct sheds. With a Dobby loom, many possibilities are available. This vastly increases the number of cloth designs available to the weaver. The advantage of a Dobby loom becomes even more pronounced on looms with 12 shafts, 16 shafts, or more. Dobby looms expand the weaver's capabilities and remove some of the tedious work involved in designing and producing fabric. Many newer cloth design techniques such as network drafting can only reach their full potential on a Dobby loom. Scope of a Dobby. The scope of Dobby is limited between a tap and a jack rod. The number of shafts that can be actuated by a Dobby varies between 6 and 40. Theoretically, Dobby can control 48 shafts maximum. However, practically it can control 36 shafts in case of wool and allied fibers. Again, for cotton and allied fibers, it can control maximum 24 heeled shafts. In these cases, heels are operated by jacks and levers. Longer sequences. Another advantage to a Dobby loom is the ability to handle much longer sequences in the pattern. A weaver working on a treadled loom must remember the entire sequence of treadlings that make up the pattern, and must keep track of where they are in the sequence at all times. Getting lost or making a mistake can ruin the cloth being woven. On a manual Dobby, the sequence that makes up the pattern is represented by the chain of Dobby bars. The length of the sequence is limited by the length of the Dobby chain. This can easily be several hundred Dobby bars, although an average Dobby chain will have approximately 50 bars. A computer-controlled Dobby loom takes this one step further by replacing the mechanical Dobby chain with computer-controlled shaft selection. In addition to being able to handle sequences that are virtually unlimited, the construction of the shaft sequences is done on the computer screen rather than by building a mechanical Dobby chain. This allows the weaver to load and switch weave drafts in seconds without even getting up from the loom. In addition, the design process performed on the computer provides the weaver with a more intuitive way to design fabric. Seeing the pattern on a computer screen is easier than trying to visualize it by looking at the Dobby chain.